Hi, it's great to see you all here on a typical Seattle summer day. So it's wonderful to see you from so many universities and so many countries. And this summit, I hope you will find really interesting and exciting about the future of computing. We have a great program of research talks and three major themes. The themes are machine learning, the cloud, and big data. I'm actually not so happy about big data. I prefer to characterize it in the examples that I see by 3 V's: volume, variety, and velocity. But be that as it may, big data is the phrase that we use. So machine learning and the cloud can, I should have a new slide at some point. And the next one. Great. Okay. Is about making informed, intelligent decisions, putting together data with huge amounts of computing power, with clever algorithms and machine learning to help you make decisions which will transform not only the business world, but I also think can help with the critical problems facing humanity today. So I would like to show a couple of examples of how machine learning, the cloud, with data can actually help with more immediate challenges. Solving the climate change and all the other problems and medical problems of the world is a long-term problem. But I'd like to take an example of forest fires. In Western USA, we're plagued with the increasing frequency and severity of forest fires. And this is an example, a tragic example here. In Yarnell, Arizona, a few weeks ago, 19 firefighters lost their lives when the wind changed and so on. What's slightly disturbing is that Cliff Mass, a professor in atmospheric sciences at UW and our local weather guru, published a detailed analysis of what was known at the time from real-time weather data, from predictions, from computer simulations, and he concluded unequivocally that hours before the incident, it was clear that there was a real threat. So, what can we do about it? Well, fires are not just a problem in the USA. In the summer of 2007 in Greece, there was severe drought conditions, and there have been 3 consecutive heat waves of over 105 degrees Fahrenheit. There were over 3,000 serious forest fires from the period of June to September, and the most destructive was in August, and it got out of control. It was threatening the outskirts of Athens, and this is a headline from the Telegraph showing that 56 people were killed in that fire. The fire was finally extinguished in September. So the outcome of those fires that summer in Greece, it burnt 670,000 acres of forest, killed over 80 people, and destroyed more than 2,000 buildings. So how can machine learning and the cloud help prevent or minimize such disasters in the future? So after this summer, this terrible summer in Greece, Microsoft employees and researchers in Greece and here went together to see if they could do something about it. And what they did was work with Greek university professors to build intelligent decision support systems to help firefighters. They chose to deploy it not on the mainland, but on a Greek island. And on a Greek island, a serious fire could be catastrophic, could be existential threat. So what the system does, it models and visualizes the risk of fire ignition, and also, given the weather conditions and the wind conditions, it simulates the fire propagation. The data sources included predictions of the computer weather model, real-time data from sensors and satellites, the topography of the island with the vegetation and the forest cover, the road networks, the locations of emergency vehicles, the history of fires in urban and agricultural areas, and of course had links to fire and emergency services. What the cloud gave them was on this island, it gave them access to compute and storage resources at a scale that was not possible locally. What machine learning gave them, it gave them the computation to use their algorithms with this data to make probabilistic risk predictions, and that was the key. So with this system, it's now deployed, fire crews can identify dangerous weather conditions, they can identify critical fire risk areas, and they can take some remedial action. So it's clearly possible if we had such a system deployed in Arizona, it might have helped with the firefighters at Yarnell. I visited Austin, Texas in January. I was giving a keynote at the American Meteorological Society. And afterwards, I paid a visit to the Texas Commission for Environmental Quality. Now, I didn't expect this agency to be high on Rick Perry's agenda, all right? But it is. Even though in Texas, I'm not allowed to say climate change, I have to talk about periodic climate variation. But the reason is clear. This is a lake bed in Texas. And this was in July the 4th this year. The reason is water management. Texas has had several years of extreme drought over much of the state. I mean, this shows the picture from the drought monitor. The brown and the red are either severe or extreme and exceptional. That's beyond severe and moderate and drought and all these other things. So huge parts of Texas are really suffering. Water shortages and how you distribute this water that you've got are critical questions. Farms, cattle and crops, and even cities are now being threatened by water shortages. The problem is very real. So a farmer upstream gets the water and the farmer downstream goes out of business. So what they've been trying to do is actually manage the water distribution systems. And so what we're building with them is a water management intelligent decision support system. Uses the machine learning and the cloud with data from river routing simulations, satellite photos, real-time river data, and historical information about water usage. So machine learning and the cloud can really make a difference here and now. And on your seats, you'll find one of these. If you want to apply to use some of free Azure resources from our cloud, you're welcome to have a look at that. The other topics at the meeting, which are exciting, just picking out a few, are genomics and quantum computing. In genomics, David Heckerman in my eScience group is using machine learning to help new ways to design vaccines for diseases as varied as the HIV and the common cold. The interesting thing, he's also using, or hoping to use, these algorithms to improve spam detection in email. Quantum computing is particularly interesting to me, since I edited Richard Feynman's lectures on computation, and it was Richard Feynman who first predicted the possibility of a non-Turing machine quantum computer. So I'm looking forward to learning about progress in topological qubits. The other session that caught my eye is a session on publishing and perishing in the 21st century. When you can distribute your research on the web and make digital copies for free, it changes the game. There are many more things you can do. And I thought I'd show this slide from a talk that Bill gave in 2005 at Supercomputing, which shows a new era of reporting. It shows that there are different ways of there's the traditional review process, but there's also other ways of measuring impact, and that's what this panel will be discussing. The other thing you can see from this is from the electronic version, you'd like to go to the software that did the simulation, run it again, show a different view. You might want to go to the data and look at the data. But that implies that the data has to be available. So Jim Gray had this vision of all scientific data online. So the vision for this global digital library for science was that you can go from a research paper to go to the supporting data. You can add your data, you can make new connections, new discoveries, and then publish your results linked, of course, to your data. So Jim believed that such an open data platform would both increase the speed and the efficiency of the way we do research. And of course, we have the White House memo in February of this year, which is actually all about open access to federally funded research. That's research that you and I have all paid for with our taxes. So we should be able to see it, is the position. My view is that I'd like to make it impossible for researchers to ignore the research results of others. Impossible to say they didn't know about it. So I'd like to hear your ideas of how we might help make this a reality. So I'm sure you'll find something of interest in the program, but the summit is about the future of computing, and I've talked about technology. The future is about people as well as technologies, and you can see people in that diagram. Most of the future jobs are predicted to be in computer science and engineering, and the question I'd ask is the IT industry doing enough with the universities to help interest young people in following a career in our field? Microsoft Research is playing our part in fueling the future. We'll offer a wide range of programs. You've heard about the faculty fellows. Picking another number here, 35,000 students and faculty have been at events organized by Microsoft Research since 2008. But last week, I was in the UK meeting the Minister of Science and Universities, and he highlighted a different problem than I've heard here. He highlighted that IT companies were not happy with the skills that UK graduates came out with from the universities. I actually think in the US, the situation is better, possibly because of the long-established intern programs we have between universities and Microsoft and other IT companies. Just to pick another number here, Microsoft has about 1,000 interns a year for 1,000 researchers distributed over 7 labs across the world. I believe that internships are of great benefit both to industry and to the student. But the question I'd leave you with is, should industry be doing more to help universities prepare their students for a career in IT? I look forward to hearing your thoughts on these questions in the next 2 days. So finally, the summit is about the future of computing, whether you're using machine learning and the cloud to develop whole new businesses or to fight fires. But ultimately, of course, the future of computer science and IT industry is about people like yourselves. It's about us. I hope you have a great meeting. Enjoy the summit. Thank you very much. Great. Well, now, thank you very much for that. We're happy to recognize our 2013 Microsoft Research Faculty Fellows, and I'll ask Harold Javid to join me on stage. Harold.
Thank you. These are the faculty fellows. No, we'd like to bring them out one at a time and present them with their award and greet them here with all of you. So the first faculty fellow we would like to greet today is Anima Anand Kumar from the University of California at Irvine. Congratulations.
Thank you very much. Well done. Great.
And will Michael Milford from Queensland University of Technology join us?
Thank you very much. Michael, well done. Thanks very much indeed.
And then Russ Saludnikov is joining us from University of Toronto.
Russ, great to see you. Well done.
And Michael Shapira from the Hebrew University of Jerusalem.
Michael, great to see you here. Thanks very much.
Monica Tentori. She's come to us from the Center for Scientific Research and Higher Education in Ensenada. And finally, Ryan Williams. Welcome. Stanford University.
Ryan, great to see you. Thanks very much.
Katrina Liggett from the California Institute of Technology was not able to join us today. So this is our group of 2013 Microsoft Research Faculty Fellows.